Hi, this is Anirban from IXIA. Today our topic of discussion is BGP LS. In next few minutes, I would talk about what are the features of BGP LS that we have added support in IxNetwork 8.0 release, and then I demonstrate how each of these features can be configured and used with IxNetwork. So let us first take a look at what are the features supported. We have added support for BGP or BGP plus link state emulation as well as extensions for segment routing. The non-VPN link state capability is added for BGP capability negotiation. Then node, link, IPv4, IPv6, prefix and LRIs are supported, and also the BGP LS path attribute. And we have added support for sharing ISIS and OSPF v2 IGP topology information through BGP LS, also for BGP protocol IDs of direct and static configuration. There is also support for BGP attributes like communities, external communities, AS path and segments, cluster for BGP LS and LRIs. We have also added a feature of suppressing hellos for IGPs, that is ISIS and OSPF, to help in some use cases of BGP LS. The Wireshark analyzer has been enhanced to display BGP link state TLVs, and we have also added a graphical view of BGP LS learned topology in IxNetwork. So mainly the following two standard drafts are supported. First one is the core BGP LS draft. This is the core BGP LS draft, and the second one is the extension for segment routing. So here is how the demo will progress. So I'll be using back-to-back IXIA ports with ISIS as an example IGP. I would start explaining how to configure different settings for BGP LS. I'll show how to configure prefix pools, simulated topology, how to get the graphical view, and how to enable traffic engineering and segment routing. We'll also look at hello suppression and how to see the BGP LS statistics, and then we'll do we'll add OSPF to this configuration and see how to configure in OSPF. So let me open IxNetwork. I'm starting with the blank config, going to scenario wizard, adding new topology, adding one chassis. This might take a couple of seconds. Okay, getting one port. So for BGP LS, it is part of BGP. So we have to add the BGP protocol here from routing switching, and also since the first I am configuring for ISIS IGP, let me add ISIS also. Okay, so going to the other port, this is the back-to-back topology I am adding. Same configuration here. I don't need 10 routers here. Let me configure only one. Okay, so since these are back-to-back ports, let me configure the IPv4 addresses with some random network. Okay, for BGP, first let me configure the PR IP addresses. Okay, and this is the default configuration. This is iBGP. Okay, so let me go to the scenario view. So I'm in BGP peer now. So to enable BGP LS capabilities, we need to go to the capabilities tab, and this link state non-VPN option has been added now. The moment you enable this, the BGP LS related tabs will be opened, will be accessible. We need to do the same thing in the other side, enabling link state non-VPN. And we also want to see the learned info for BGP LS NLRIs. So let me go to the learned route filters and enable the filter link state here. Same here. Same on the other side. So that's it. Okay. So let me go to the BGP-LS tabs now for a quick pass through. BGP-LS ID and BGP-LS instance ID can be configured from the BGP-LS subtab. Let me not configure it right now. Let me have them as default values. The other tabs that open up, that is communities, external communities, ASPath, etc., uh, are for advanced options of configuring different BGP path attributes. If enabled, these get added to the BGP update message along with link, node, or prefix NLRIs for the emulated router or the simulated topologies. Let me enable one of them. Just enable the enabling the community here. So this will be applied for the emulated and the simulated routers, but not for the prefix pools. For prefix pool, there is separate configuration. Okay, so for now what I'll do is that for one of these ports I'll be configuring some prefix pools, and after that I'll bring up the connection and examine the learned info on the other side as well as the packet capture. So starting with the prefix pool. So from this add network group option, let me add some IPv4 prefix pools. Okay, so I'm in the network group. Now please note that these prefixes will be available for both the IGP, that is ISIS here, and also BGP, BGP-LS. So these routes will get advertised by BGP-LS for both ISIS and BGP-LS. We can disable either of them, but by default both are enabled. Okay, so here is the ISIS L3 route range. Let me make it deactive. In the BGP IP route range, it is active, and for BGP LS also I need to enable this BGP LS prefix. So from here I can control whether it will be a static route or a direct route. So these are the two protocol ID options available in the BGP LS draft. Let me configure static here. Okay, we could also configure the community, external communities, or other ASPath or other path attributes from here for this, which will be applicable for this routes. So all other BGP related attributes will be applicable here. So with this configuration, let me start the protocols. So this is the range is 200.1, and let me give a count here, maybe 10. Sorry. Okay, so I am now starting the protocols. Oh, before that, let me enable the capture. Starting capture on one of the ports. Starting the protocols. This might take a few seconds. Okay, so looks like it has come up now. All right. So let me first have a look at Wireshark. I'm selecting only BGP packets. So having a look at the BGP open message first. So in BGP open message, I should be seeing a capability for link state. Yeah, so there it is. So there are many capabilities advertised by IXIA port. One of them is the link state capability. Okay, so next let me look at the update message. Update message, I want to look at the update message that is sent by the site where I have configured the prefixes. Okay, so this is coming, this actually on the 5112 source IP address side. So I'm selecting that update message, and from there going into it. So if I go to the MP reach NLRI, we can see that this is a link state packet, and this is the topology prefix NLRI. Here you can see the link state identifier ID, autonomous system TLB and all. The IP reachability information is here. So I have configured 10 routes here. So all these are part of here. Okay, so this is how we are showing seeing this from Wireshark. Now let me go to the other side, learned info. So the BGP-LS peers have communicated between these two ports. The peers of these two ports are peers, so they have communicated, and the information sent by one of the ports now should be available in the other port. So to see the BGP-LS learned info, right click on the BGP row, and from there get the link state learned info. Okay, so in learned info, as you can see, there are 3 tabs. So first tab is for the node and link NLRIs. The second tab is for IPv4 prefix NLRIs, and the third tab is for IPv6 prefix NLRIs. Since we have not configured any IPv6 prefix here, so there is no IPv6 now information shown here. Okay, but we have the node and link NLRIs. There is only one node since I have not yet configured any simulated topology. So there will be only one node, and this is also learning the since this is learning the information through ISIS, so it is showing the ISIS will be displaying the information for the same port from where I have configured the router. So both the router information, the back-to-back routers information is present here. And also the link that is between these two routers is present. So this two node NLRIs and the link NLRI is present here. So if you look at this IPv4 prefix information, we can see that all these static type of prefixes have been learned, are coming now in the learned info. And so let me go through a little bit more on this node link learned info. The first column is for the protocol ID. So since we have configured ISIS, it's showing ISIS here. If it was learned through OSPF, it would have shown OSPF. And this is the node name or type. So for node NLRI, it will show node here, and for link NLRI, it will show link. Then there are other useful informations like router ID and peer router ID, local and peer IPv4 addresses, IPv6 addresses, etc. Okay, and if you can, if you see here, there are a lot of options for T traffic engineering fields and also for SR related fields. Since you have not configured anything for these fields, so they are not showing anything right now. We'll come to that when we configure SR and T. Okay, so let me close it. Now let me quickly show you the how to see the topology diagram. So please note that since there is only one topology here, one couple of routers with one connection, so this will be a small diagram. So I'll also configure a large topology a little bit later, and then we'll have a look again. So just for starting. Okay. I'll come back to this little bit later. Closing this. Okay. So now next I'll configure simulated topology behind the topology 2 router. Okay, first let me delete this. By the way, we can have both, no issues, but just to avoid any duplicate entries there, I am removing the prefixes. Now let me configure the simulated topology. For this, adding a network group and selecting network topologies. Let me configure a topology of 10 fully meshed nodes. Okay. So here I am in the configuration for simulated topology. The simulated interfaces are there. IPv4 addresses, you can change these fields. Let me start the topology here. Wait for a few seconds so that it comes up. Okay. Getting the link state learned info. So here you see there are many node and link learned infos now. So since we have 10 routers, each connected to 9 other, so you should be seeing 9 link NLRIs here for every node NLRIs. Okay. And if you click on this and now see this topology diagram. So this is what we have learned. We have learned the topology. So background for this is black by default. It can be changed from here. Black, white, light gray, etc. Let me keep it the default black. So this layout can be changed by the user by selecting different layout algorithms. There is a drop down list for that. Let me select circular here. We can move around the nodes to get a better view. Now, hovering on one node or link will display information for that node or link. You can see that hovering information display, and also on the right side you will see this. If you click on it, the right side it will show this node info. Clicking on a link will display the information for that link, and there is please note that there is an arrow mark here. So this arrow mark will indicate if this link is bidirectional or single directional. So if a link is unidirectional, it will show the arrow mark in that direction. Then user can select multiple nodes and make a cluster out of it. Okay, for example, let me select these 3 nodes here, and then right click on it, and there will be an option of clustering 3 nodes. So this is this helps in case the topology view is big and user wants to make it small or fit into this diagram. We can uncluster it also. Then the view can be zoomed in, zoomed or zoomed out. Also, user can annotate the elements, put up some comments in the view. For example, if I click on one of the nodes, we can put a name there. Okay, and if you want to put up some comments on this page, go to annotate, click on annotate, and come back to here and put some text here. The graph can be saved as an image. There is a save graph as image option. If you click on it, the image displayed here, you can save it as a .bmp file. This will include all the annotations that you have given. On the bottom left corner of the topology information, there are some useful information displayed like number of nodes, number of links, etc. This can be hidden using this button. So if there is any change in the topology, that will you need to refresh the learned info again. I mean refetch the topology information to see it get reflected. So this doesn't get dynamically reflected. You need to fetch it again. Okay, so let me now move on to segment routing and traffic engineering, how to enable them. I'm stopping it. So for simulated topology, simulated routers, let me go to the ISIS simulated bridge. The segment routing can be enabled from here, and all the segment routing related values can be configured from here. Traffic engineering can be enabled from here also. for the emulated router, that can be enabled, segment routing can be enabled from here. Okay, so let me enable them on the uh, simulated topology side. I have enabled them. So let me start the protocols. Wait for a few seconds. Okay, so now just want to see the learned info for how this is getting populated for the traffic engineering and segment routing fields. Going to the link state learned info. And now we are able to see the T related fields getting populated. Maybe we can look at the capture again. Stopping the protocol. Starting again. Let's look at one of these update messages. So this is a link NLRI. And this is the BGP LS attribute. So here we can see that default metric T related information is getting updated. Administrative group also. Okay, so let me move on to the next topic now. So that is the option of suppressing the hellos. So in this use case, duty may be a route reflector. IXA emulated router establishes only BGP-LS peering with duty, but no IGP peering or neighborship is established. So let me go to the emulated router for the ISIS option. No, it is in the ISIS L3 if tab. There it is, suppress hello. So suppress hello can be enabled from here. The other side also we need to enable it. Okay. So with this option enabled, ISIS or OSPF IGPs will not send out hello or establish adjacencies, but the ISIS OSPF topology configuration will be available for BGP LS as IGP information in the XIA emulated router. So those will get advertised, whatever the simulated topologies or prefix pools that you have configured, but the IGP session will not get established. Let me also start the capture. I should not be seeing any ISIS packets now. So as I only BGP packets. The color for ISIS protocol in the protocol stack will be shown as green. Since the hello suppression is enabled. So even though there is no neighbors in full state, it will be showing as green. Okay. So let me now go to the BGPLS related statistics view. The BGPLS stats are not displayed by default. User needs to go to the stats selector and then add the stats for BGPLS. So this from here the ls node update tx to link state NLRI RX errors. So these are the stats for BGPLS. To add these stats, just select them and add it in the view. So now you can look at these BGPLS related stats. So there is node update, then TX and RX, then node withdrawn, TX and RX. Same for link advertised and link withdrawn, and then IPv4 prefix advertised TX and IPv4 prefix withdrawn TX. So all those stats will be available. And there is also stats for error. Now let me quickly show how OSPF is configured with BGPLS instead of ISIS. Okay, so I'll be removing the ISIS stack from these two topologies and adding OSPF. Sorry. Okay, so I'm making this as point to point. Let me also add prefix pool and a network topology here. Okay, so with this configuration, I'm going to start the protocols. Now let me look at the learned information. So now as you can see, all the protocol IDs are updated as OSPF protocol IDs. Getting link state topology learned info. Please note that there is slight difference in color how we display the ISS or OSPF routers. So if in a topology there are ISS and OSPF both, so they'll be displayed in different colors. From the OSPF side, to enable hello suppression, go to the OSPF interface and the advanced tab, and then there is this option for suppressing hello. So that is all I have today for BGP LS. Thank you very much for listening.